Hello everybody and welcome to my YouTube channel. I'm Michael and this video is about a lathe I bought about 5 years ago from Precision Matthews. It's a 1030V model. It's the big brother of the 1020. It just has a little bit longer bed. The rest of the machine is exactly the same. This video will address installation, setup of the machine and then some upgrades and improvements I did to the machine to fit my needs. I want to point out this is a pure hobby workshop. I don't run a business out of here, and I'm not sponsored by anybody. Okay, so let's start with the stand. The stand is based on a Husky 7-drawer tool chest. I customized it, reinforced it in the inside with steel angles, added a base frame to lift it up a little bit, and also to give me the chance to attach some removable casters. These are casters where you can just lift up the machine, move it somewhere and drop it to the floor. And if you ever need to move the machine again, you just take these casters, pop them in, and here you go. The stand, as I said, has 7 drawers, which gives you plenty of space to store all your measuring equipment, your cutting tools, your regular tools, the chucks you have, and so on and so forth. Plenty of space. I like to keep all the tools and all the equipment I need to work on a machine close to the machine. That avoids the necessity to run around and look for stuff. So works quite well. I have plenty of storage space here. When I set up the machine, I had one little issue, and I pointed out here. Let me turn on the LED light. I covered that with this funny looking towel that's normally not here. Just put that on because the light, the LED light interferes with my camera. So let me turn it on. Back here, I hope you can see that. I lowered this camera a little bit, sorry for that. So back here, you see this hole in the wall, which I drilled because the spindle has a spindle bore of 1 inch to allow for long stock. I only had 16 inches between the wall and the machine, was a little bit short. So I drilled this hole and now I can feed long stock through the wall. This hole didn't hurt me. It's hollow space underneath the stairway. It's not accessible anyway, so that works quite well. On top of the stand and underneath the machine is a chip tray which comes with the machine, and I added this, it's a baking thing. I added this and put a little wooden piece on here that just slips right in here, and the majority of the chips just fall in here. Makes it very easy to clean up. You just take it out and put it in a waste basket. You're done. Also, I added a wooden cover for the bed that if I'm working on something, it cannot damage the bed if it's falling down. And the little cover here, when I remove this cover, I have another one here when I change chucks. I just put it underneath here, that if a chuck falls, that it's not damaging the bed. And when I move the carriage forward, you might see here is another cover which goes underneath the lathe. So when I'm turning something, all the chips and so on, they don't fall in the bed. They're covered here. They're just with a brush, you get rid of them. It works quite well. Here you see a carriage stop. I made that actually also on a Precision Matthews machine on a mill. It is, the machine does not come with a carriage stop. It comes in very handy. You can do very repetitive cuts. Just adjust it to the distance you want. Lock it with this lever, and then you're done, and then you have a fixed stop here. Okay, moving on with some minor improvements. For example, the speed adjustment for the lead screw has 3 positions, A, B, C. But interestingly, it's not slow, medium, fast, or fast, medium, slow. It's medium, fast, and slow. So I just labeled that because it's kind of hard to remember that. Same thing here with the lead screw. This lever does even a cross feed or a feed in Y direction. And I just labeled it because you might forget which one is what. Very simple, but helpful for me at least. Also a small thing, typically can only turn on the spindle when this cover is closed. I didn't like that too much. I use it when I have a lot of small chips producing and stuff. Normally I keep it open. There's a micro switch in here which prevents you from turning on the machine when it's closed, so I just remove that. Okay, next topic are the lock screws for the cross slide and the carriage. The lock screw for the carriage is located here, right underneath this extension for the DRO sensor. And it's a hex screw which you cannot reach with an Allen key. So I replaced it with a regular screw, and you just have to have a very narrow or slim wrench, and then you can slide that in, easy peasy. You can lock that, very simple. I made this cover for the DRO sensor myself. I had to cut in a little slot here to make space for this wrench. That works great. The other lock screw for the cross slide is this one, and the screw is a little bit longer normally, and it almost hits the DRO sensor. And so I shortened this and cut an Allen key in shape, and now you can reach it and can adjust it easily. Next up is the tool holder. The Precision Matthews comes with this, I think it's called an AXA tool holding system, which is great. And it comes with this compound, which is also great, but I wanted more stability, especially when I cut off something. I wanted something more stable, so I built this tool holder base. It's a solid piece of metal. I have a slot in here, 2 slots in this base plate, in this base plate, and then this base for the tool holder just slides in here, and you can move it over. Sometimes it's valuable being able to adjust the distance to the chuck here. So I have both options. Also, when you adjust the angle of this guy, what most people do probably, they move this thing all the way forward against the spindle to get a 90-degree setup. I didn't want to do that. I 3D printed this little part. It's very simple. You just take this part, put it against here, and you have perfect 90 degrees. Lock it down, and it has a little notch here. It slides in right here. Slides in right here, has its own place, and done with it. Also added 2 covers for the T-slots, so I don't have to clean the chips out every time. Next up is the compound, which normally sits on top of this base plate. Like I said, I replaced it with a solid piece of metal for more stability, but sometimes I use it. The compound had a little bit too much play for me here between the tool holder and this shaft. So I put a piece of brass on the lathe and made this little bushing which slips on here, and now I have 0 place. I don't think it matters much when it's locked down because there's enough friction to hold it down. But when you turn it, I don't think that it's very repetitive, and so I feel more comfortable with that. The lock screw for the compound is a regular hex screw, so I replaced it with a little aluminum wheel. So I don't need a tool to lock it now. And on this side of the compound is the handle. Comes with a handle. This is part of the handle. I just added this Delrin piece, and I added a standard hex axle. So this is my own handle. It slips on here, and it's much easier to turn because you have more diameter to turn that than doing this one here. So I feel more comfortable with that. And also, when it's bolted down here, the standard hex adapter gives me the option to slip one of these guys on here, and then you just have like a power feed for the compound, temporary power feed for the compound. It comes in handy if you turn long tapers. It comes in very handy to have that. Actually, it also gives you a nice surface because it's very smooth. The steady rest for this machine, which sits on the bed like that, comes with these brass fingers here. I replaced those by homemade fingers with little bearings, and that runs smooth and gives a nicer surface, and you don't have to lubricate it all the time. So small improvement, it's quite a lot of work to do that actually. Next topic is the tailstock. The tailstock is longer than the one you see here. I put this tailstock on the mill and milled the surface back for one reason. As I said, the lathe came with an installed DRO, and this DRO sensor takes away space. So when you move the tailstock forward, at this point roughly, it started colliding with the DRO sensor, and that gave you more distance to the spindle. Now, the problem you have is in order to get with your tool to the workpiece, if you have a long distance here and you have a dead center or a live center in here, you might run out of travel of the tailstock. Also, I do not like to run the tailstock all the way extended because you get more runoff. Then first I tried to abort one of these extended live centers, but again, the longer they are, the more runoff they have. So what I did is I cut the length of this tailstock a little bit. That gives me about 1.5 inches more movement, and I don't face this problem anymore. The next thing I did to the tailstock, I installed a DRO. Now, one word to DRO in the lathe. A lathe really does not require a DRO. It's mandatory for a mill as far as I'm concerned. A lathe, you really don't need it. But I work with millimeters and with inches, depending on the project. And that makes a huge difference if you have a DRO, because if you have, you can have all these dials either in inches or in millimeters. The Precision Matthews Lathe is inches, and if you make a part in millimeters, it is a constant calculating exercise that is much easier with the DRO. And the same is true for the tailstock, of course. That's also in inches, so I don't need to see that's a leftover because it's Chinese made. In China, they have the metric system. The scale here is still in millimeters, but the dial here is in inches. So what I did is I installed a DRO, which is not permanently attached, so you can dial it without it. If I need it, I can put that forward. Then here's a little wheel. You move that here, and this slips into this groove. You fix it, and now the display here gives you the indication. The beauty is you can set that to 0 at any point. If you want to drill, for example, a certain depth, you just set it at 0 the moment you contact the workpiece, and then you drill whatever millimeters or inches you want. You can switch between millimeters and inches, so it comes in very handy. And if you don't need it, you just loosen the screw, turn it 90 degrees, and you're ready to go. The lathe comes with 2 chucks, a standard 3-jaw chuck and a 4-jaw chuck. The chuck attaches to the spindle with, just turn this here, like that, just pops in there. This centers the chuck here, the spindle ring, and you pop it in. There's a marker, a 0 marker, always put it in the same place, pops in. Then you turn this ring, you tighten these screws, and you're done. Now I want to have 2 more chucks. One was Collet Chuck. Comes in very handy, especially if you do small pieces. And a bigger chuck, that is a 6-inch chuck, also fits on here. Now the issue I had is it's almost impossible to find a chuck with this locking system. Some chucks have, like, there's a thread in here and you screw them on. There's a huge disadvantage of those chucks is you cannot run the machine in reverse, because then the chuck loosens itself. So I prefer this system, but they don't make these adapter plates. So I made that myself. It's just a piece of, it's a very mild tool steel, and put it on the lathe. And the first thing I did, I machined this inside flank, which fits on the spindle center here. And then I mounted it directly to the spindle with these 3 bolts. And then I turned the outside, the inside in here, the adapter in here, the diameter where this attaches to the chuck, I turned that diameter directly on the spindle, which pretty much eliminates all run out. Provided you always mount the chuck with a little 0 indication here in the same position. You should have 0 turnout. I measured it pretty close to 0, so it worked quite well. Approaching the end of this video, just a small gadgets or pieces are built. If you want to turn between centers, you need some kind of, I think it's called a lathe dog. So I built one which pops right in here in the standard spindle, and it locks with the same system. But what I did, and what I would highly recommend, especially if you're turning at higher RPMs, I weighted this, calculated the mass needed, and produced 2 of those to balance the spindle. This weight, if you're running it at whatever 1500 RPMs, creates quite of an imbalance, and with these counterweights you can eliminate that. Also, as mentioned before, when you're working with very long stock, the spindle bore here is 1 inch, allows for 1 inch stock to be fed through the spindle. That's why I created this little hole in the wall. But if you have long stock, it has a tendency to wobble. So what I did is I created this collet which pops on the end of the spindle, and then you can just tighten that, and it gives you more leverage to stabilize long stock. So wrapping up, a few more small details. If you work with softer materials, aluminum, brass, and so on, and you have a finished surface, you really don't want to put that in steel jaws. So I created these little slip-on protectors they slip on the jaws, they have a soft surface, and you don't have marks on your finished surface. The issue you have if you build one of those, you will create runout. They are not super precise, so if you just put something in to sand it with sandpaper or something, they're great. If you want to have super precise measurements, don't use them. Also, I built myself an extended chuck key. Sometimes it's helpful. You don't have the space to have a key which is a little bit longer. And finally, what you see here is a pressure regulator for MQL, a micro quantity lubrication system. I have that on all my machines, on my mill and on my CNC mill, which creates kind of a air lubrication mist. On the lathe, I very rarely use it. I use air when I cut knurls, not when I'm pressure knurling, then you don't need it. But cut knurling, you don't want to have the tiny little chips in the grooves and then you cut them again, and then it makes a little bit messy surface. So I have pressurized air here. It's regulated downwards from 120, around 120 psi here in the workshop, down to between 20 and 30. And then I have a nozzle which provides air directly to the cutter and getting rid of the small chips. And that is pretty much it. All right, that's the end of this video. Thank you very much for your attention. I will follow up with more videos, but then about usable projects. I made 4 videos now in a row about setting up machines and workshop and so on. I also sometimes build valuable stuff, toys and games and all kinds of stuff. So the next video will be about something productive. Thanks again for your attention. Hope you enjoyed it, and I'm looking forward to see you very soon. Thank you.